Let's look at this question. As always, you can pause the video to do it first. Okay, so let's read the question, and it's a mechanics question from extension 2 trials of Sydney Boys. I wouldn't say it's a very difficult question given it's question 4. However, this is a very important question because its principle is applicable to a lot of mechanics questions which can appear as hard questions as question 16 or 15. So let's look at it. A particle is moving along the x-axis, initially moving to the left from the origin, so v initial is smaller than 0. Its velocity and acceleration are given by this and this. So let's look at the choice. Which of the following correctly describes its subsequent motion? So it is a multiple choice, but I think it can also, if they want to adapt it, it can be a short answer question. They can ask you a question like this: which of the following describes its subsequent motion? So let's look at it. It moves only to the left, alternatingly speed up and slowing down without stopping. It moves to the left, alternating slowing to a stop and then speeding up. It slows to a stop, then heads to right forever. It oscillates between 2 points. So how do we tackle these questions? There's one very important thing we need to remember. So how do we know when we have a specific displacement? If, for example, x equals to 1, and I want to find its velocity from using this, how do I know v when I know v squared? It could be positive or minus. So this is a question, and the way we deal with it is to look at the initial condition, and we check if the velocity changed signs or not. That is, we need to check if the velocity approached 0 or not. So suppose there's a this is time, this is velocity. If initial is positive, and it's always positive, then you can know at any point of time it's positive because you haven't changed signs. So as it's in the question, it's the same as well. We need to look at if v equal to 0 or not. And so one way to do it is by contradiction. If we let v equal to 0, suppose it was 0 at some point, you would get this absurd result. Now this is for extension 2. You guys should know how to do the algebra, so it's contradiction. That's why it's impossible to approach 0. So velocity is never 0. It was initially negative because it says it's moving to the left from the origin, so velocity initial is smaller than 0, and that's how we can know that velocity is always 0 because it never changed signs. So this is how we analyze this part of the question, and this part of the question should be easier. So we should know that it only moves to the left, it only moves to the left. It won't come to a stop. It will not come to a stop as we just analyzed, and it won't oscillate, means at some point v equals to 0, so this is also wrong. So the other half of the choice, you obviously need to look at the acceleration part, which is this part, and basically it's asking you if it's speeding up and slowing down without stopping, or does it slows to a stop and then speeds up. Actually, you already know which one it is. It's A, because it never slows to a stop. It never stops, so B is wrong. So but we're still gonna look at the acceleration, although if it's in an exam, you don't need to, you already get the answer, but let's still look at it anyways, because it's just weird, isn't it, to have a part of the question that's not used. So let's see if this is correct. It speeds up and slows down without stopping. It's alternating. It's very likely because it's a sine function and a cosine function, and they're known for their periodicity, like the oscillates. So if we graph the acceleration, we can find out that indeed it is positive and negative like this. So right, because for this one, graphing it can be hard. I mean, So I use the table of value method, like these special cases. When you plug in the value, get the exact value, and you should know this. Also, you should know that if this is a function, it have this property, that is, the period is 2 pi. I mean, it could be a smaller one, but 2 pi is definitely one of its period, and so that's why we just draw this part, and the following, they're just the same. They're just the same, repeating and repeating. So we see that when acceleration is negative, it slows down. When acceleration is positive, it speeds up. So it is alternately speeding up and slowing down, which means that A is completely correct. So the gist from this question, I think, is why I put it here. It's not because the question is hard. I think the question is not even well made, because once you know V doesn't equal to 0, B, C, D is all wrong, then you just know it's A. However, the way to think about it is very important. You know the initial case. Then you find V equal to 0. Did it ever equal to 0? If it didn't, then it's easy. It's always smaller than 0. Yeah, so this is the gist of this question, and this is how you solve the question of V is positive or negative. So hope you enjoyed the video. If you like it, don't forget to press the like button and subscribe.